Okay, my ninja. A very warm welcome to yet another power-packed session. Today we are going to discuss quadratic equation, complete quadratic equation. We are going to discuss all the concepts involved. We are going to discuss the most amazing questions along with PYQs as well. So I hope the agenda is clear. The session is exclusively for 2025 aspirants. However, if there are some aspirants of 2024, JEE Main 2024, so they can also watch this lecture just to revise, refresh, revisit the concepts and some PYQs, important PYQs. Yes. But before I get into more details, I want you to confirm that, okay, ma'am, Ninja ma'am, you are completely audible and completely visible, right? So that we can proceed with today's session. And also, do like this session. And along with that, do share this session with your fellow JEE aspirants because we expect healthy competition and a nice interaction throughout the session. Yes? All right. Okay. I guess I am perfectly audible, perfectly visible. And yes. Just awaiting your confirmation. Yes, I can see comments pouring in. Hello Akshay, hello aspirant, hello Siddharth. Good evening. I guess aspirant has just confirmed that yes ma'am, you're completely audible, completely visible. So I don't want to waste any time and I'm just gonna get into the details of the chapter, right? So what are we going to cover in today's chapter, today's session, quadratic equations? Let me just go through it. Okay, all right. So you can see that quadratic equations we are going to cover relations between roots and coefficients. By the way, this you have already studied a little bit glimpse of this session. The topic roots and coefficients you have already studied in class 10. Then we are going to study nature of roots, right? So nature of roots also you are aware about the discriminant and all, but we will study from the basics, and there are some things covered in your grade 10. This is exclusively for class 11th that we are going to cover. Transformation of equations, absolutely important topic as far as your JEE Main is concerned and as far as your calculus portion is concerned. Then we have common roots and location of roots. So these many topics are there for Yes, these many topics we are going to cover. Okay, all right, shall we start? All right, so first, the very first topic, let me just begin with relation between roots and coefficient. But before that, let me just show you what a quadratic equation looks like. So a quadratic equation looks like this: ax square plus bx plus c is equals to 0. This is your equation. And the moment you by y, so that will become quadratic polynomial, or you can call that as a quadratic expression. So either polynomial or expression, right? This expression is a basically quadratic expression. What are the conditions related to quadratic equation? In what condition we are going to call ax square plus bx plus c as a quadratic equation? So the very first condition is your leading coefficient a cannot be equal to 0. Right? Because what I want is I want my term a to exist. Right? Ax square I want to exist. I don't want my ax square to vanish. Because if it vanishes, then it is not a quadratic equation. I hope you understand this point nicely. Second is all the coefficients a, b and c belongs to real number. So these two conditions are absolutely related to your quadratic equation or quadratic polynomial or quadratic expression. Okay, all right. Yes. Akhil is asking me something using the board. Pen is not good for listening to, ma'am. Pen is not good for listening. I don't understand this. Okay, all right. So this was all about quadratic equation, right? Now how to solve a quadratic equation? So to solve, we have seen various methods in our grade 10, right? By suppose by factorization, that is splitting the middle term, or what you can do is by completing the whole square, and directly what we can do is we have this formula which will give you direct solution of any quadratic equation. What is that formula? So the formula is nothing but x is equals to minus b plus minus square root of b square minus 4ac upon 2a, right? Where if you carefully observe this quantity which is residing inside, which is sitting inside the square root, b square minus 4ac is this quantity. So this quantity is nothing but your capital D, right? B square minus 4ac is your discriminant, and as the name suggests, it discriminate the roots of the quadratic equation. It's differentiate. The b square minus 4ac is whether your roots are real or equal or imaginary. We will get into those details, but right now just remember that this is called capital D, right? And this is your quadratic equation, ax square plus bx plus c is equals to 0, whose roots, let us assume, are alpha and beta. Okay, whose roots are alpha and beta. Okay. Yes, Akhil, okay, noted. I have taken your feedback and I'll be super soon resuming to boards, to smart board. Do not worry about that. Okay, and I'll make sure that learning point of view say there is no basically no there is no problem, okay, for you. Okay, all right. Now alpha and beta are roots of this quadratic equation. Okay, now let me talk about sum of roots which is denoted by capital S. Okay, so sum capital S is nothing but alpha plus beta, that will be equal to minus b by a, right? Yes, capital S sum of roots is minus b by a. What is b? This. What is a? Leading coefficient, right? And product of roots capital P, you can write product of roots alpha into beta is nothing but c by a. Here c is the constant, a is the leading coefficient, the constant term upon leading coefficient, right? So these two formulas are extremely important, and I hope that majority of students do remember these two formulas. But what they do not remember is alpha minus beta, that is difference of roots, that too inside the modulus. So difference of roots, modulus of alpha minus beta, if you can see over here. So difference of root is nothing but square root of d upon modulus a, right? So this will be square root of d upon modulus a, right? Now I'm gonna tell you that if you don't remember this, na, even if you remember this alpha mod of alpha minus beta is equals to root of d by modulus a, then also you can just calculate it. Let me just show you how. So you know that alpha minus, let me just show you this formula. Alpha minus beta ka whole square. Tell me, alpha square plus beta square minus 2 alpha beta, or rather let me just write it as alpha plus beta whole square minus 4 alpha beta, right? Can I write this way? Yes. So now do you have alpha plus beta? Yes, ma'am, you just taught us. Do you have alpha into beta? Yes, ma'am, definitely you just taught us. So can you calculate alpha minus beta in terms of these two quantities? Yes, definitely. So even if you do not remember the formula, even if you do not remember the alpha minus beta formula, then also you can calculate it. I hope this is clear. Okay. All right. Let us now proceed and let us do a very important PYQ, an important PYQ which will only based on, so till now we have actually studied anything. We have almost revised whatever was taught in grade 10. Right? Nothing new. Till now we have not studied anything new, anything tricky, anything conceptual, right? So let us solve this question and you will realize that how easy questions they can ask from quadratic equation. Okay? So this question clearly you can see was asked in 2021, right? JEE in 2021, which says A, B, C are in arithmetic progression. Let the centroid of the triangle, so centroid of this triangle with vertices A, C, 2, B and A, B is given. This is your centroid. Okay. So very first thing, just by reading half of the question, I can just write down some information. First thing is A, B, C are in arithmetic progression. So I can clearly write that 2B is equals to A plus C. That is my first equation. Second would be now side of the triangle, right? So let me just write x coordinate. So A plus 2 plus A by 3 is nothing but 10 by 3. This is x1 plus x2 plus x3 by 3 is nothing but your 10 by 3, right? So from here, what you're going to get is 2A is equals to 8. So A is coming out as 4. Similarly, what you can do is y1 plus y2 plus y3 upon 3 is equals to, right? So yes, C plus B upon 3 is equals to 7 by 3. So that means 2B plus C is given as 7. This is your second equation. So can you see first equation and second equation? Now you know the value of A, by the way. So 2B will be equal to 2B minus, so you can just shift this C towards the left hand side. So 2B minus C is equals to A, which is 4, right? So these are the two equations and the two unknowns. Just add these two. 4B will be equal to 11, right? So you're going to get 4B is equals to 11. B will be nothing but 11 upon 4. And the moment you put the value of B in any of the equation, you are going to get C as well, right? You're going to get C as well. Okay. Yes, Akhil, we will be discussing. We all will be actually taking care of your April attempt. Do not worry about that. So after like mathematics paper, we all will be doing your April attempt, right? Okay. Cool. Okay, Akhil. I hope that it resolves your doubt. Okay, so now what you can do is you can just plug in the value of B over here, right? So 4B is equals to 7 plus 4, 11, 11 by 4. So the value of C also you can calculate. So all the three values now you have, A, B and C, right? And now what you can do is, okay, so now you need, so it is given that alpha comma beta are the roots of this equation, okay? Alpha comma beta are the roots of this equation. So you know A, you know B, so that means you know this equation, and what you are looking for is this. Alpha square plus beta square minus alpha beta. So how you are going to calculate? Let me just show you. So yes, A is equals to 4. We have just calculated. B is equals to 11 by 4. We have just calculated. The moment you plug in the value of B in either of these two equations, you are going to get C, which is equals to 3 by 2. Right? And now the quadratic equation is what? AX square plus BX plus 1 is equals to 0, whose roots are given alpha beta, and you are looking for the value of alpha square plus beta square minus alpha beta, right? So you are looking for alpha square plus beta square will be alpha plus beta whole square minus 2 alpha beta, and there is one more alpha beta over here. So finally what you want to calculate is alpha plus beta ka square minus 3 alpha beta. Now who is going to tell me the value of alpha plus beta? Sum of roots. Sum of roots, by looking at this equation, I can say that sum of roots is minus b by a and product of roots is 1 by a, right? So minus b by a will be, okay, so minus of 11 by 4 4 is 16 ka square minus 3 times alpha beta will be 1 by a, that is 1 by 4. So yes, this is what you're going to get. Just calculate it and write down your answer. Yes, have a look. Have a look. So yes. So can you see that what did we do? Alpha square plus beta square minus alpha beta. Now alpha square plus beta square can be written down as, yes, alpha plus beta whole square minus 2 alpha beta. And there is one more alpha beta, so it will become minus 3 alpha beta. Alpha plus beta value is minus b by a. You know a, you know b. So what are you waiting for? Just plug in the value, right? And this. So what you're going to get, can you see 11 ka square is 121, 16 ka square is 256 minus 3 by 4. So, and if you're going to solve this, what you're going to get is this, 71 by minus 71 by 256. So the correct answer of this particular question is matching with option D. Yes? Clear? Yes, yes, yes. Okay, okay, all right. So let us just move on to the next concept. But before that, do you know that ax square plus bx plus c is equals to 0? If I say that alpha and beta both are roots of this quadratic equation, so I can satisfy alpha in it. That means a alpha square plus b beta plus, sorry, plus b alpha plus c is equals to 0. A beta square plus b beta plus c is equals to 0. So both alpha and beta, which are apparently the roots of this quadratic equation, can be satisfied in quadratic equation. This is very simple funda, very basic concept, which we forget sometimes while solving the question, right? So that's why I'm reinforcing it, that you will get such situations wherein you have to satisfy this. Okay. Now we have another question. Can you see the question on your screen? Yes. Can you see the question on your screen that, okay, if alpha and beta are not equal and alpha square is equals to 5 alpha minus 3, beta square is equals to 5 beta minus 3, right? Now, if I see these two equations carefully, basically we've got, the moment I start reading the question, now I am telling you one more very important point. Let us forget quadratic equation. Let us forget everything. Let us forget backlog express. Let us forget everything. Please understand. Okay, let us forget this question for a moment, for 2 minutes. Give me 2 minutes. I want to take this moment. So you know what, I was teaching 2024 aspirants, your seniors, and I was teaching 2023 aspirants as well. I taught 2022 aspirants, 2021. I'm teaching all the aspirants since like past more than 8 years I'm teaching, right? So every year, the moment I like the JEE main comes closer now, so I ask them that what are challenges you are facing, what kind of challenges you are facing. So every JEE aspirant told me this, that ma'am, I don't know how to solve problem. I'm facing problems in problem solving, basically, especially mathematics. I know the theory, I understand everything, but when it comes to solving problems now, I'm not able to do that. Why? So basically at that moment it becomes very difficult for me to tell them when they only have 1 month, 2 months left. So at that moment it becomes very difficult for me to tell them that do this, do that, right? Because they have very less time in building their problem solving skills. But if you are a JEE 2024 5 aspirants now, you have this opportunity. What opportunity? So the moment you start reading the question, or any teacher trying to teach you now, I never teach like this, okay, this is the question, this is the solution. Nobody teaches like this. So they always teach you like this, okay, alpha not equal to beta. Now this is a mathematical condition, that means roots are distinct. Can you see? In this, roots are distinct. So understand that how your teacher is approaching the beginning part of that particular solution. It will help you in building your problem solving skills, which majority of JEE aspirant faces. So you will get edge over all those aspirants who are not doing that, who are just running behind second step, third step, fourth step. No, that's not we do it. That's not how we do it. And that will not help you in long run. So now can you see this? The moment I see this, na, alpha square minus 5 is equals to 5 alpha minus 3. So can you see that these two statements are actually similar statements? Only the replacement part is alpha and beta. In the very first equation involving alpha, I have replaced, basically the question examiner or question creator has just replaced alpha by beta or beta by alpha. So basically this is a quadratic equation only. X square is equals to 5x minus 3 if I write now. Or what I can do is x square minus 5x plus 3 is equals to 0. Where you can satisfy alpha and beta. Do you understand this? Now, the moment you start listening to me, na, if I show you the solution, it will be like solution showing thing. This is teaching and this is problem solving skills building, right? We are building problem solving skills as well. ठीक है? Cool. So So now I got this thing that, okay, I have a quadratic equation x square minus 5x plus 3 is equals to 0. Who has, this equation is having two real and distinct values basically. That's what I understand from this, okay. Now what I'm looking for is equation whose roots are alpha by beta and beta by alpha. I'm looking for a quadratic equation whose roots are this and this, right? So now do you know a concept? If you don't know, let me just tell you this concept. So the concept says that, can you see the concept? That if S is sum of roots and P is the product of roots, then we can easily write the quadratic equation, which is x square minus sx plus p, right? So for any quadratic equation, or if you have to write any quadratic equation, you will need two things, sum of roots and product of roots, okay? So what you are looking for is S, which is alpha by beta plus beta by alpha. If you know this, then half of your problem will be solved. We will be writing the quadratic equation by using this particular x square minus sx plus p. So we are looking for S and P, where S is this. What about P? So P will be product. So alpha by beta into beta by alpha. So clearly my capital P is coming out as 1. Alpha alpha cancel, right? And beta beta also cancel. Now let us calculate this. So S will be equal to, the moment I take LCM, alpha beta, alpha square plus beta square. ठीक है? Okay. Alright. Now alpha square plus beta square. Who is going to tell me the value of alpha square plus beta square? It will be alpha plus beta ka whole square minus, yes, minus 2 alpha beta. So alpha plus beta ka whole square, can you tell me? It is 25. This is going to become 25, right? Let me just delete this. Yeah. So alpha, so 2 alpha beta. So this is going to become 25 minus alpha beta. Alpha beta, so alpha plus beta is actually 5. Alpha beta is what? 3. So 25 minus what? 2 3s are 6. So you're going to get 19. Alpha square plus beta square is 19. Alpha beta is nothing but 3. So sum of roots is coming out as 19 by 3. Can you see this? Sum of roots is 19 by 3, right? Now what you can do is you can just plug in the values. Let me just do that. Okay. Yes. So x square minus sx plus p is equals to 0, where your s is nothing but alpha by beta plus beta by alpha, and p is nothing but alpha by beta into beta by alpha. That is 1. So x square minus sum of roots I have to calculate, product of roots I have already calculated, right? And over here alpha beta, alpha square plus beta square, which is nothing but sum of roots 25 minus, we have 6 upon 3. So this is 19 by 3. Put the value over here, 19 by 3. Take LCM, 3x square minus 19x plus 3 is equals to 0 will be your quadratic equation. Can you see this? Yes. So I can see aspirant has already told me, okay ma'am, option D is absolutely right. So yes. How do you find this question? Actually, I to find this question absolutely on point, good, concepts clear, conceptual clarity we've got, okay, everything, and problem solving skills we have developed. Okay, all right, cool. So D option is absolutely right. Now we have another question in our plate, and this is actually a question, this type of question you will definitely see in your 2025 as well. And let me just tell you, not only in 2025 JEE Main, but in 2024 April, you are going to see this type of problem from quadratic equation. Okay? All right. So let us just dive into this problem, understand this problem nicely, so that our 2025 attempt, if we see that question in 2025, we are first of all confident enough to attempt it, and attempt it like a pro, that yes, I'm gonna get +4 in that. Okay. So let us understand what this problem trying to say. Alpha and beta are two real numbers such that alpha plus beta is 1 and alpha into beta is minus 1. Okay, all right. Sum of roots is given as 1. Okay, but actually in this question nothing is mentioned about quadratic equation, right? Okay, let us just check. Alpha plus beta is equals to 1 and alpha beta is equals to minus 1. That's what I can see. And it is given that Pn is nothing but alpha raised to power n plus beta raised to power n. Pn minus 1 is given by 11 and Pn plus 1 is given by 29. The value of Pn square is what we need to figure out. Okay. All right. Clear? All right. So this is what is given. Till now I have not done anything. Till now I have just written whatever was given to me. Did I write anything extra over here? No, not at all. So let us understand that this actually is hinting towards a quadratic equation whose sum of roots is known to us and product of roots is also known to us. You are aware about this, right? If I know sum of roots, if I know product of roots, I can write the quadratic equation. So quadratic equation will be x square minus sum of roots 1x plus product of roots, so minus 1 is equals to 0. So this is my quadratic equation whose roots are alpha and beta. So this is the very first thing I can interpret. This is something which I have interpreted, right? I have interpreted. Clear? Okay. Now how to proceed? I can clearly see that if both the roots are like, we can satisfy both the roots over here. So what I can do is alpha square can be written down as alpha plus 1, right? Can you see this clearly? Alpha square can be written down as alpha plus 1, right? Yes. Okay. And yes, if I talk about alpha cube, if I multiply alpha on both the sides, so alpha cube will be what? Who is going to take alpha square plus alpha, right? Yes. Okay, if I multiply alpha, and if I do one more thing, alpha power 4 will be equal to what? Alpha cube plus alpha square. That means now I know the pattern. Now I know the pattern, right? What is the pattern? Understand the pattern, realize the pattern. If alpha raised to power cube plus beta raised to power cube is given to me, what I can do is alpha cube will be replaced by alpha square plus alpha and beta cube will be replaced by beta cube plus beta, right? So this is my P3. Do you agree? This is my P3. I have taken P3 because in the question it is written as Pn is equals to alpha raised to power n plus beta raised to power n. So I am just taking an example. I am trying to understand the pattern, that what is P3. Now P3 is becoming, can you see alpha square and beta square can be clubbed together and alpha square and beta square is nothing but P2. Alpha plus beta is nothing but P1. Okay. So this is something which we need to understand from this expression. What do we need to understand? So we need to understand that P3 can be P2 plus P1 and similarly P4 can be written down as P3 plus P2, right? So Pn can be written down as Pn minus 1 or rather Pn plus 1 can be written down as. So Pn plus 1 can be written down as Pn plus Pn minus 1. That's what I can understand, that this relation I can establish. Yes. Yes, Meghashri. Okay, Priya. Yes. Hi, Priya. Welcome to the session. Did you understand the whole logic? How did I achieve this statement? Because this is extremely important in solving such questions. Okay? And do not worry, I'll be telling you the shortcut as well. Right? Yes. So, yes, in the question itself, they are asking us in the question that, okay, they are talking about Pn first and then Pn minus 1 is given, Pn plus 1 is given and Pn square value they are asking. And now I have established the relation. So, Pn plus 1 I can write as 29. Pn is I am unaware about and Pn minus 1 is minus 11. This is what is given to me, right? This is what is given to me. Yes. I'm going to repeat. Do not worry about it. So Pn, the value of Pn will be what? Tell me 40. And Pn square will be equal to 6. Okay, plus 11. Sorry, it is given as plus 11, not minus. Okay, plus 11, plus 11. Oops. It is plus 11, so plus 11. So 29 minus 11. ठीक है? 29 minus 11 is 18 and Pn square will be what? 324. 18 ka square. Okay? Yes, I'll be repeating. Do not worry, I'll be repeating. Shall I repeat one more time? Yes? Let's do it one more time. And do not worry, I'll be telling you the shortcut as well. Okay? So yes, for who asked me to repeat? Meenakshi. Yes. Let us understand this one more time. So in the question, it is given that alpha plus beta is 1, alpha beta is minus 1. The moment I look at these two equations, I feel like why don't I write x square minus sx plus p is equals to 0, which is quadratic equation whose sum of roots is 1. In the question it is given alpha plus beta and whose product is what? Minus 1. So why not I plug in the value of s is 1. So x square minus x minus 1 is equals to 0. This is my quadratic equation whose roots are alpha and beta. Do you agree till here? Yes? Meenakshi is saying now don't repeat. Stick to one thing. Shall I repeat or shall I not? Right? So now x square is equals to x plus 1 is what I am going to get, whose roots are alpha and beta. Or I can write directly alpha square is equals to alpha plus 1. Right? Can I write it this way? ठीक है, alpha square is equals to alpha plus 1. ठीक है? So or if you allow me, can I multiply alpha in this? If I multiply alpha in this, I get alpha cube is equals to alpha square plus alpha. If one more alpha, what do I get? Alpha raised to power 4 is equals to alpha cube plus alpha square. So now I have understood the game and same is gonna repeat with beta also. Same thing is gonna become same with beta also. So now I know the game. That if I see alpha raised to power n plus beta raised to power n, right? This is my Pn. Pn is what? Alpha raised to power n plus beta raised to power n. So it can be written down as alpha raised to power n minus 1 plus alpha raised to power n minus 2. Like that I can write it. Okay. Or what I can do is clearly, yes, now listen to me carefully. If somebody has given me Pn plus 1, that will be alpha raised to power n plus 1 plus beta raised to power n plus 1, right? Now alpha raised to power n plus 1, you know the game, right? It can be written down as alpha raised to power 1 plus alpha raised to power n minus 1. And similarly, beta raised to power n plus 1, beta raised to power n plus beta raised to power n minus 1. Right? Why? Because now we know the pattern. Alpha raised to power 4 was alpha cube plus alpha square, right? So basically, 1 power we are decreasing, nothing else. So now can you see this alpha raised to power n plus beta raised to power n can be clubbed together, and alpha raised to power n minus 1 and beta raised to power n minus 1 again can be clubbed together. So this is Pn, this is Pn minus 1, this is Pn plus 1. This is what we've got. This is very important. Now Pn plus 1 is 29. Question mein it is given. Pn is what they are asking. Pn minus 1 is given as 11. So the value of Pn is 18. And they are asking you Pn square, that is 18 ka square. So that would be 324. Santosh, yes, Pn plus 1, why? Tell from Pn plus 1. Santosh, are you still having any doubts? So just watch this video because I have taught this twice, right? So just watch this video one more time, you will get, right? I have covered everything. Okay, now let's focus on the upcoming things. Let's not get stuck to the previous thing, right? Let's just focus on the new things, okay? So now we have studied, till now we have studied very little about the quadratic equation in terms of concepts. So we know that for a quadratic equation, sum of roots and product of roots. But for a cubic equation or for a power 4 equation, how is the sum of roots written? How is the product of roots written, right? So let us just check, okay? Let us just check. So we are given with a cubic equation. And we are looking for sum of all the roots of cubic equation. So we are assuming that alpha, beta and gamma are the 3 roots for this cubic equation. Okay? Alpha, beta, gamma, 3 roots of cubic equation. Sum of all the roots will be minus b by a. Can you see there is an invisible minus sign over here? So minus b by a, right? So sum of roots for quadratic also started with this, minus b by a. And then what you need to do is you need to take 2 roots and take product of those 2 roots, alpha, beta. Other 2 roots, take product of 2 roots, beta, gamma. And then gamma, alpha. And then sum of product of roots taken 2 at a time. So this is what we call sum of product of roots but taken 2 at a time. So alpha, beta, beta, gamma, gamma, alpha ka sum will be equal to positive of c by a, right? And last, taken 3 at a time, product taken 3 at a time. So we are only having 3 alpha, beta, gamma. So that will be minus d by a. That's how we write, right? So this is what we call as a relation between coefficients and roots. Yes, and now what about power 4? So for power 4, ax raised to power 4 plus bx cube plus cx square plus dx plus e. So we will be having 4 roots. Alpha, beta, gamma, delta, right? Sum of all the roots will again be minus of b by a. That is the fixed, that is for sure fixed. Okay, all right. Now let's talk about sum of product of roots taken 2 at a time. That means alpha, beta, beta, gamma, gamma, delta. And then all possible combinations which we can make, that will be plus c by a. Can you see? And now some product of roots taken 3 at a time. So alpha, beta, gamma, delta, gamma, delta, alpha, alpha, beta, delta will be minus d by a. Can you see the alternate plus minus sign over here? And last but not the least, e by a with a positive sign, product of all 4 roots, alpha, beta, gamma, delta, right? So yes. Clear? Clear, clear, clear. I hope that if you receive 5 wala quadratic or nth polynomial or nth equation as well, so you can just easily write. Now you know the pattern, now you know the drill, so you can write it. So I have a very easy peasy lemon squeezy question for you all. And yes, so I just want you to attempt this question. Yes. Are you going to attempt the question? Try attempting it. Try attempting the question. Alpha, beta and gamma are the roots of this equation. So sum of roots. Who is going to tell me the correct answer? Sum of roots. Yes, yes, yes. So sum of roots will be alpha plus beta plus gamma. That will be equal to minus b by a. We all know that, right? Yes. So Meenakshi is saying ki 4 by 3. Okay. All right. Yes. Very good, Meenakshi. है ना? Aspirant is also saying 4 by 3. Very good aspirant, है ना? So this was a googly question, and they give such type of question in JEE main as well. And what you don't pay attention, and then you complain that okay, JEE is difficult. Tell me, is JEE difficult? Is JEE really difficult? Are you paying attention? Are you paying attention? No, you are not. Basically, the problem is not that JEE is tough. The problem is that you don't pay attention. The problem is that you take things lightly. The problem is that you are not that alert, right? And they play, NTA play on that thing. ठीक है? Especially, yes, Meenakshi. Yes, Meenakshi. 100%. है ना? तो careless mistake is what makes JEE difficult. Because JEE is not difficult. You people make JEE difficult. Are you getting my point? This proves these type of questions they give, and the careless mistake you do, this mistakes make JEE difficult. These kind of mistakes lower your percentile. ठीक है? So yes, 3x cube plus 0x square plus 1 is equals to 0. But you know what? Like, be happy about it. Okay, I have made this mistake right now in the session, in the class, before my JEE attempt, so that I won't make this mistake again. Now I won't make this mistake again. First of all, the Ninja Ma'am has scolded us a lot on this small mistake. That is one reason. And second reason is I have made one mistake one time. I would become a fool if I JEE main, right? So this is minus b by a. So can you see minus 0 by 3? Minus 0 by 3. So 0 is the correct answer, option A. ठीक है? Yes. Concepts are also not tough. The point is is this concept tough? Is this concept tough? No. Concepts are also not tough. You just make some careless mistakes and you just write incorrect answer. You end up ticking incorrect answer even though you know the concept. Concept is not that difficult. Okay. Now let's talk about the nature of roots, which we all know. Little bit though we all know about the nature of roots, right? So it depends upon the discriminant, which I was telling you. That discriminant is nothing but b square minus 4ac. Okay? Yes, Santosh, your answer is right. Okay. So yes, it's good that your answer is right. But again, see what is happening. So basically there are some students who will mark incorrect answer, which some of you already did. So just be happy that okay, I made a mistake in the class and I've got this opportunity of making mistake before my JEE attempt, so that I will make less mistake, almost no mistakes in my JEE attempt, right? And there are students who will be actually ticking the correct answer. So just be happy, but don't be overconfident, right? Just understand, okay, I know some things. There are a lot of things which I have to know, right? This will give you guarantee. Both of students will improve. Okay, definitely. Discriminant b square minus 4ac, it will actually give you the nature of roots. So basically any real number can only have 3 values: positive, negative and 0. So when your discriminant, that is b square minus 4ac, becomes a positive quantity, that means that your roots are real and distinct. That we all know. I am just reinforcing the facts. Discriminant, if it is equal to 0, then we say that your roots are real and equal. And if your discriminant is coming less than 0, then you say that you have non-real roots. Okay? You have non-real roots. Clear? Right? Now let us get into some more details which we have not studied in our grade 10, which are exclusive for class 11th, right? So if your discriminant is not a perfect square, can you see this? These are the roots of quadratic equation. So discriminant is positive, that means the value which is inside the square root is positive. But it is not a perfect square. For example, your discriminant becomes 2. So it will be x is equals to minus 1 plus root 2, something like this. So discriminant inside the root and it is not a perfect square. So that means that you are going to get irrational values, right? And irrational values you are going to get provided that your a, b, c, that is ax square plus bx square plus ax square plus bx plus c, that is coefficient of your quadratic equation, are rational, right? So let me just tell you one more time. If in the question it is given to you that your coefficients are rational, right? A, B, C are rational. Rational means free from radicals and roots. Then, if your discriminant is not a perfect square, then your roots will be conjugate irrationals. That means if one root is p plus root q, another root will be p minus root q. What is the condition? That my d is not a perfect square, and my coefficients a, b, c are rational. In that case, you will get conjugate irrationals. And if your d becomes, for example, square root of 4, square root of 16, square root of 9, square root of 25, square root of 100, then your roots will become rational. Okay, I hope this is clear. Okay, now if your d is equals to 0, if your discriminant is coming equal to 0, then you can put d is equals to 0 over here, and you are going to get equal roots, and the value will be x is equals to minus b by 2a. In such cases, what will happen? Your basically quadratic equation will become a perfect square. X square minus 6x plus 9 will become a perfect square. Right? Yes? Clear? And one very important thing related to your discriminant less than 0. Let me just show you about the discriminant less than 0. So for discriminant 0, you will have imaginary roots, and always remember, imaginary roots always occur in pair, in conjugate pair. So if one root is p plus iota q, another root will be p minus iota q, provided that your coefficients are real. A, b and c all are real. Then what will happen? Your all the roots p plus iota q, p minus iota q will be conjugate complex numbers. Okay? Alright? Clear? I hope this is clear. Okay? Alright. Now, we have a question, and I want you all to attempt this question. So the question is asking us about the roots of the quadratic equation. The question is asking us about the roots of the quadratic equation. ठीक है? Are real, rational, different, imaginary, whatever. So who is going to tell me? Discriminant, which is b square minus 4ac. Let us calculate. So here my b is what? Minus of 2a plus b. So minus 2a plus b is my capital B. Minus 4 ac. A is 1 and c is what? 2a square plus b square. Right? This is your discriminant. Can you calculate discriminant? 1000%. How? So can you see that this minus 2 ka square will become 4. So this 4, both 4 I can take out common. This will become a square plus b square, right? Plus 2ab, correct? Because minus ka square will become plus. So this is 4 I have taken common. So 4 is gone. This minus 2 is also gone. And minus 2 a square minus 2b square. That's what I am getting. That's what I am getting. So can you see if I just a square minus 2a square. So my discriminant actually is, if I take minus sign common, a square minus 2a square is what? A square minus 2a square is what? Minus a square mein minus common, so a square plus b square, and we are left with minus 2ab. So your discriminant is minus 4 a minus b ka whole square, which is less than or equal to 0, right? That means your discriminant is either negative or 0. Okay? Is either negative or 0. That's what we understand from here. Okay? So yes, can I say that my roots are imaginary first of all because they are negative? Okay? And one more thing, if A is equals to B, both are equal, then your discriminant becomes 0, right? So yes, x square minus 2 and 2ax plus 2a square is equals to 0. So we can just calculate this. So x square minus 4ax plus 4a square. So it would be, yes, equal roots basically. Hai na? So from here, yes, negative or 0. So imaginary and different is one option which may be correct. Right? So yes, they actually forget about imaginary and different. Okay, so this question has some technical error, or they can just give us this information: A is not equal to B. This should be mentioned in the question. Yes, A not equal to B. So if A is not equal to B, then your discriminant is strictly less than 0, right? So that then only we can say that my root is imaginary and different. Okay, all right. Yes, है ना? So one information they should give, that A and B are not equal, because if A and B will become equal, my discriminant will become 0 and my roots will be real and equal, right? Real and equal I am gonna get. So that's why A not equal to B should be there in the question, so that option D is absolutely right. I hope this question is clear to you all. Now let's jump into another question which is from JEE Main 2019. Yes, JEE Main 2019. So the question says number of all possible, very good question, absolutely good question. The number of all possible values of alpha for which the roots of quadratic equation are rational numbers. Yes. Okay. So roots of quadratic equations are rational numbers. Want how to make my quadratic equation rational or roots rational. So condition of roots to be rational. And a rational roots की condition, let me just tell you rational roots का condition. So first of all, your ax square plus bx plus c में rational roots के अंदर your a comma b comma c should be rational. Second thing, D should be perfect square. So can you see, this is your quadratic equation. A is 6, which is rational. B is minus 11, which is rational. And alpha is integer. Right? In the question it is mentioned that we are going to only have integral values of alpha. So first condition is fulfilled. Now discriminant should be perfect square. Okay, this is very important condition. This is a concept actually. Condition of rational roots. Please keep this in mind. Calculate discriminant. Discriminant will be 121 minus 4 into 6 into alpha, and I want my discriminant to be a perfect square. So 121 minus 24 alpha. ठीक है? Alright. What we can do is we can start putting the values and see where it goes. Right? So first of all, I can do value of alpha is 0, because the moment I put alpha is equals to 0 now, so my roots will become rational because 121 will be a perfect square. Now let's talk about alpha is equals to 1 and minus 1. So if my alpha becomes positive in values, oh my god, so that means our job is extremely easy. We don't have to go minus 1. Just put alpha is equals to 1. The moment I put alpha is equals to 1, what do I get? So I get 97, so which is rejected at all. Alpha is equals to 2. So that means 121 minus 48, right? 121 minus 48. What do you think? What do you think? So I have these values, yes. So this is it. Alpha is equals to 0 is satisfying, but this is not a positive integral. Alpha is equals to 1 will not satisfy. Alpha is equals to 2 will not satisfy. Alpha is equals to 3. That means 121 minus 24 into 3. So 4 3s are 12, 72. So 121 minus 72 will be 8 or no, 9. So 8 and 1 9 and then 49. Yes, 49. So alpha is equals to 3, which will give you discriminant is equals to 49, which is a perfect square. Now alpha is equals to 4. So 24, 4 4s are 16 and 4 2s are 8. Okay, 24 into 4. 4 4s are 16, 4 2s are 8, 96. So basically 121 minus 96. So this will give you 525, which is a perfect square. So alpha is equals to 4 is also accepted. Now alpha is equals to 5. So 121 minus 24 into 5 will give me 120. So this is 1. Again, alpha is equals to 5 is also accepted. So what you can do is, now after that, after alpha is equals to 5, the moment your discriminant is going to become negative. That means imaginary roots. You are looking for rational numbers, right? Yes, so 3, 4, 5. That means option D is absolutely right. Right? Okay. Clear? So alpha 2, alpha 3 is satisfying. Alpha 4 is satisfying and 5 is satisfying. 3, 4, 5, that means 3 values. No. Meenakshi is saying, ma'am, multiple option question. No. Why do you think so? Number of positive and integral values. They are not asking you the values of alpha. They are asking you how many values of alpha are possible. So 3, 4, 5, that is 3 values are possible. I hope that you understand this, Meenakshi. Okay? All right. Clear? Now let us get into my favorite section, which is transformation of equation. Transformation of equation. Okay? So let me just tell you about this, that, okay. Yes. So if ax square plus bx plus c has roots alpha and beta, your question says that write an equation, roots are very important, whose roots are 2 alpha and 2 beta, right? So this is the problem statement. This is the problem statement. Okay. For all of those who have not liked my session, I just want to ask that why are you not liking my session? Okay. All right. So this is transformation of equation, wherein they give you something. They give you a quadratic equation. They say that alpha and beta are the roots of this equation, and you need to find equation whose roots are 2 alpha comma 2 beta, alpha by beta, beta by alpha, or you need to write 1 by alpha, 1 by beta. So basically they give you various combinations of roots, and they want you to write the equation in terms of A, B and C. How do you do that? Okay. So let us say the very first step. So I will tell you step by step, and then I will be telling you the shortcut. Okay. Are we ready for step by step solution of the problem statement? And then I'll be giving you the shortcut. What can be better than this? Okay, that we are understanding the concept, step by step solution as well, and we are understanding the shortcut as well. Best method to study anything, any topic, any chapter, right? You know the concept, you know the shortcut. What else? Okay. So that means so we need to write, basically what we can do is, we need to write the equation whose roots are alpha dash and beta dash. Let us say that I am about to write an equation, a quadratic equation whose roots are alpha dash, where alpha dash is 2 alpha and beta dash is 2 beta. Can I say that? Can I say that? Can I say that? Clear? Yes. है ना? So I am going to write an equation whose roots are alpha dash and beta dash. So what I am looking for, understand this nicely. I am looking for an equation who will satisfy alpha dash and beta dash, right? One thing I know, that this original equation which is given to us it will definitely satisfy alpha and beta, right? So ax square plus bx plus c is equals to 0 will satisfy alpha for sure. So can I satisfy alpha in this? A alpha square plus b alpha plus c is equals to 0, right? So step number 1, I hope clear. Step number 1, this is step number 2. So step number 1, what we will do is, we will take alpha dash and beta dash and assign it to 2 alpha and 2 beta, whatever they are asking. Step number 2, satisfy alpha in the original equation. Now step number 3, you will see step number 3 and your mind will be blown that what I'm going to do. So I'm going to do one thing, very, very smart move I'm going to do. So from here, can I calculate the, yes, alpha will be alpha dash by 2, ma'am, and beta will be beta dash by 2. So what I can do is, this alpha will be replaced by alpha dash by 2 in the step number 3. Can I do that? Yes, can I do that? So now a alpha square, so a alpha dash by 2 ka square, can you see? Plus b alpha dash by 2 plus c, and this will be equal to 0. If you solve this, what will you take LCM and everything? What will you get? So you will get a alpha dash square, okay? Let me come over here. Plus we have 2b alpha dash plus I have 4c is equal to 0, right? Now understand. This is your step 3, okay? Now step number 4, the last step. Step number 4, the last step. So what you have got is a alpha dash square plus 2b alpha dash plus 4c is equals to 0. This is your alpha dash, okay? This is your alpha dash. And now step number 4 is replace alpha dash by y or x or t. Replace by x, okay? So ax square plus 2bx plus 4c plus 4c is equals to 0 is your quadratic equation in which alpha dash can be satisfied. That means the root of this quadratic equation is alpha dash, and similar method say you can prove the root of this quadratic equation is beta dash. So root of these two quadratic equation is what? 2 alpha and 2 beta. So that's how you are going to do that, okay? All right. Yes, welcome Uchuk Puchuk. Replace alpha y and how? Yes, I'm going to tell you one more time, right? One more time. So yes, so understand, I want maximum attention over here. 4 steps in like 2 minutes. I'm going to explain one by one. Everything is connected. Connect the dots. So what we did was, first of all, it is given that ax square plus bx plus c is equals to 0 has alpha and beta, right? Has roots alpha and beta, and we are looking for alpha and 2 beta. Now let me say this problem statement in another manner, another fashion. Can I say that ax square plus bx plus c? Can I say that? So I am looking for quadratic equation which will satisfy 2 alpha, right? So I am looking for that quadratic equation which will satisfy 2 alpha, or I can say which will satisfy alpha dash. So I am looking for a quadratic equation which will definitely satisfy alpha dash. Is my problem statement clear now? Yes. Now step number 1, how to achieve it? Step number 1, that, okay, take alpha dash is equals to 2 alpha and beta dash is equals to 2 beta. That is your step number 1. Step number 2 is, now original question will get satisfied by alpha. So a alpha square plus b alpha plus c. Now calculate from here, step number 3 may calculate the value of alpha in terms of alpha dash and put this value in this equation, in this original equation, because you can satisfy alpha. So, alpha dash by 2, these two values are equal. The moment you do that, you will get this. And the last step, the final step, the moment you get this, now can you see this is a quadratic in which I can satisfy alpha dash. Don't you think that somebody took this quadratic equation which I written in the box, ax square plus 2bx plus 4c, and substituted alpha dash in it, right? So basically I am doing the reverse process. What I am doing is, I know that alpha dash can be replaced by x, and if the root of this equation is alpha dash, so I can satisfy alpha dash. If I want to write a quadratic equation with root alpha dash, I can write this. So we can switch between these two, right? Now I will be telling you shortcut to it. I will be telling you the shortcut to it. Are we ready for the shortcut? Are we ready for the shortcut? Because this is an example basically. So I just want to tell you the shortcut, right? So are we ready for the shortcut? Okay. So what we need to do is, if roots of this are alpha and beta, then the equation having roots. So for this, what we need to do is, in this equation, we just need to replace x by 2. We just need to do the reverse process. So the question is asking me 2 alpha. What I am doing is x by 2. The question is multiplying 2 in my roots. So what I am doing is dividing by 2. So that means a x by 2 ka square plus b x by 2 plus c is equals to 0. The moment you solve it, so it will be ax square plus 2bx plus 4c. Solve it, na? Take LCM, you will get this. Direct shortcut. Direct shortcut. Santosh is saying yx. Yes, Santosh. So you can just write t, because standard what we do. I teach you quadratic equation, what do we do? Ax square plus bx plus c. That's what we do, right? Okay. You can just put t also, y also, right? But standard we take x, ax plus linear equation. If I ask, say कि okay ma'am 3x plus 4. So linear equation in x. Okay. Again, now 1 by alpha, 1 by beta. So in here, what we need to do is alpha 1 by alpha. So that means x को अपन 1 by x से replace करेंगे, तो a by x, a 1 by x square plus b by x plus c is equals to 0, and what we are going to get is a plus bx plus cx square. This is b का answer. What about c के लिए? What shall we do for c? So x को you have to replace by x minus 2, right? This is your shortcut. Yes, any variable you can, but yes, any variable you can write. But if I want to show you the cubic equation, if I want to teach you the cubic equation, standard, what is standard? Ax cube plus bx square plus cx plus d. Although at cube plus bt cube plus ct plus d is also a equation, but standard is x, na? So why are we doing x? It's just a standard notation. So x को x minus 2 से कर दो, तो a x minus 2 का square plus b x minus 2 plus c, and solve it, you will get your answer. So now you understood the shortcut. Okay, shall we move ahead? Yes, Varun? So let's talk about common roots. Now this topic is NTA's like almost most favorite topic, common roots, and we have seen a question in JEE Main 2024 January attempt from this topic as well, right? So let us understand this. Let us understand common roots wala topic. Okay. Yes. So basically common roots, what is the possibility? Common roots mein you will be given with 2 quadratic equations. So in the question you will be seeing 2 quadratic equations, and the situation could be any of these 2 situations, that they will say that both the quadratic equations have 1 root in common, right? Understood? They have 1 root in common. Or what they can do is they can say that both roots are common. If both roots are common, you have to be extremely happy because this is the easiest thing they can do. Both roots are, like, you will be able to solve the question in a jiffy, and the concept is so easy. It is a 1-minute concept. The problem is what happens when they in common. I mean, the solution and the concept is a little bit lengthier. Easy, both are easy, but both roots are common is much easier. We will study one root common and then two root common. You will see, oh, like this, it's so easy, right? So first of all, understand that for one root common we have multiple methods. Okay, so let us one by one go to the multiple methods, right? So whenever they see one root common, so what is the procedure? Question, by the way, right? With all the methods, we'll be applying all the methods. So whenever the question says that these are the two quadratic equations and they both are having one root common, so what you can do is, if in case you know both the roots of one equation, that means the first equation or one equation out of both the equations is completely known to you, you can actually calculate the roots of that equation. So what you can do is you can just, so basically you have quadratic equation 1 and quadratic equation 2 and they are having one root common, right? So what you can do is you can just calculate both the roots of these two quadratic, for example x is equals to 1, x is equals to 2, and what you can do is for quadratic equation 2 you can take cases, that case 1, that suppose that common root which is mentioned in the question is x is equals to 1. That means you are taking the case that maybe x is equals to 1 is that common root. Case number 2 says that maybe x is equals to 2 is that common root. So you need to solve each and every case and get the answer, right? Okay. Alright, let me just show you how we are going to do that. So can you see the question? With the help of question, we are going to understand. Determine the values of m for which the equations this and this may have a common root, right? So these two are having one common root. So I can clearly see that the doable. Second equation, the roots of the second equation can be easily calculated, right? So let's do that. 2x square plus 3x minus 2 is equals to 0. 2x square plus 4x minus x minus 2 is equals to 0. Splitting the middle term, right? So 2x can be taken common, x plus 2 minus 1 can be taken common, x plus 2. So x is equals to half comma minus 2. That means both the roots are known to us. Now I'll be taking cases. So case number 1 says that suppose x is equals to half is that shared root, the common root of both the equations. So what we will do is, that means x is equals to half will satisfy this equation, yes or no? Yes. X is equals to half will satisfy my first equation. So let us, what are we waiting for? Put the value 3 into 1 square plus 4m 1 by 2 plus 2 is equals to 0. So 3 by 4 plus 2m plus 2 is equals to 0. So m ki value you are going to get 4 2s are 8, 9, 10, 11 minus 11 by 4. M ki value you are going to get minus 11 by 8. Yes, that's how you do it. Yes, ping pong, why will we get 4 values? No. Got it? Clear? Now case number 2 says that we are telling ki acha nahi, x is equals to minus 2 is that root which is common. So let us plug in minus 2 over here, 3 minus 2 ka square and plus 4m minus 2 and we have minus 2, right? Sorry. I made a mistake in applying the sign over here. So this is minus 2, right? So this is minus 2. So minus 2 is equals to 0. 2m will be equals to 2 minus 3 by 4. 4 2 is 8 minus 3, 5 by 4. So 5 by 8 is the value of m which you are going to get. And again, so this is minus 2 is equals to 0. So 2 to cancel, 2 is getting cancelled out. So minus 6 minus 4m minus 1 is equals to 0. So 7 minus 7 by 4 is the value of m you are getting. So m की 2 values आ रही हैं. There are 2 values of m, right? So there are actually 2 values of m. प्लस 2 है कि माइनस 2 है? सॉरी, इज इट प्लस 2 और माइनस 2? ओ प्लस 2 है, प्लस 2 है. सॉरी प्लस 2 है तो प्लस आएगा. सो 11/8 आ रहा है. ठीक है. एंड हियर प्लस 2 है तो प्लस 1 आएगा. -6 प्लस 1 तो -5/4. ठीक है. तो 11/8 -5/4. ठीक है. Clear? So you got the hang of the procedure, that in such questions where it is given that may have a common root, but the condition is one equation is completely known to you. You can calculate the roots of first equation and then you are able to take cases so that maybe x is equals to half is that common root, or maybe the second case wherein x is equals to -2 is the common root. So you are going to get 2 cases, so 2 values of m, right? So this is an incorrect answer. You can clearly see -11/8, right, is the correct answer. And yes, yeah. So this was your method number 1, right? Method number 1 clear. Now let's talk about method number 2. Yes, let's talk about method number 2. ठीक है. Method number 2 says that what you need to do is, you have got 2 equations, right? 2x square plus 3x minus 2 is equals to 0. And you have got 3x square 4mx plus 2 is equals to 0. What you can do is, you can solve these 2 equations together. This method is absolutely applicable, or this method is suitable when you are not aware about the roots of this equation, or maybe there is a case that one m is hidden over here, either here n is hidden, so you don't know the complete equation. है ना? Quadratic equation 1 and quadratic equation 2 are both somewhat unknown to you. Then what you can do is, you can apply method 2 where you can solve these equations, right? And yes, so we will solve it like that. Okay, so let's just tackle this question. Let's just understand this question. Okay, let's apply method number 2 in this question. So if you have this equation x square plus bx plus 1 is equals to 0, and if you have y quadratic equation which has again both the, can you see clearly, completely unknown to me, right? I can't calculate any root from any equation, right? Yes. So now they are saying that they have one root in common and we need to figure out the value of b. So how do you tackle it? So first of all, you can write x raised to power 4 plus bx cube plus x square plus x minus 2. What you can say that, let us assume that alpha is that common root. So what you can do is, you can just simply replace x by alpha. Replace x by alpha. So alpha raised to power 4 b alpha cube, and then you have alpha square plus alpha minus 2, right? Because alpha will be satisfied in both the equations. Let us satisfy alpha in the first equation as well. And you need to solve these 2 equations. It will be actually very, very important, very, very useful if you square this equation. Just square it so that you will get what? Alpha raised to power 4. Then it will be very convenient for you to solve such kind of equations. You are going to eliminate alpha. Basically, your target in method 2 is to eliminate alpha, right? Shall we start? Okay, just square it. So alpha square plus b alpha plus 1 ka square, right? And just open the square nicely and then solve it right away. So alpha raised to power 4 plus b square alpha square plus we have, okay, 1. Then we have 2b alpha cube. Then we have 2b alpha. Then we have 2 alpha square. And I guess yes, is equals to 0. This is after squaring you will get this, right? So what you have done is square. Okay. Actually, rather than squaring, oops. No. Actually, rather than squaring, na, yes. Do not square it because we are not able to solve it. What we can do is multiply alpha square in this. Yes. If you multiply alpha square, what will you get? Alpha raised to power 4 plus b alpha cube plus alpha square is equals to 0. This is your second equation. And this is your first equation which is given. Now, what you can do is just subtract these two. Alpha raised to power 4, alpha raised to power 4 gone. B alpha cube gone. Alpha square gone. I am left with alpha minus 2 is equals to 0. That means clearly the common root you were looking for is nothing but 2. And what you can do is you can just simply satisfy 2 in any of the equation, you get the value of b. So 2 if I satisfy over here, 4 plus 2b plus 1 is equals to 0. Can you see the value of b is nothing but minus 5 by 2. Yes? Clear? Right, so method 1 is clear. Method 2 may you just have to eliminate, you just have to solve these two equations. Let us solve one more question which was asked in JEE 2011. Yes, it is actually a very old question, but again this is a very beautiful question which will help you to understand this method. A value of b for which this equation and this equation have one root in common. Yes, it will have one root in common, right? So what we need to do is clearly that alpha square plus b alpha minus 1 is equals to 0, alpha square plus alpha plus b is equals to 0. What you can do is we can simply subtract. So these two will get cancelled out. Alpha if I take common b minus 1 and minus 1 minus b is equals to 0. So alpha will be equal to 1 plus b upon b minus 1. This is your common root, right? Now this common root can be satisfied either in the first equation or in the second equation so that you get the value of b. Let's do that, right? Yes, are we ready? So yes, b plus 1 upon b minus 1 ka square plus b plus 1 upon b minus 1 plus b is equal to 0. Okay, so it is, take LCM, just that. So b plus 1 ka square, then we have b square minus 1, then we have plus b is equals to 0, right? Have a look. Yes, so it will be b square, it will be 2b square, and then plus 1 minus 1 will be gone. We are having 2b plus 3b, yes, is equals to 0, right? That's what we are going to get. Okay, so x square plus x plus b, na? B plus 1 upon b minus 1 plus b plus 1 upon b minus 1, right? So this b will have b minus 1 ka whole square. Sorry. Here b minus 1 ka whole square, right? So yes, the moment you solve it, you will get the value of b. Let me just show you the solution. Yeah. So you are going to get a cubic in b. Solve it and get it, okay? You are going to get a cubic in b. Let me just solve it in next page. So b plus 1 ka whole square, b square plus 2b plus 1 plus b square minus 1 plus the last thing, can you see? B square, so b square minus 2b plus 1, right, is equals to 0. So 1 cancel, 2b square plus 2b plus b cube minus 2b square plus b is equals to 0. Can you see? So b cube plus 3b is equals to 0. So b square plus 3. So b is equals to 0. Root 3 iota minus root 3 iota. Right? So these three values are possible for b. And yes, we are looking for a value of b. So we can clearly see that this is wrong, this is also wrong, this is also wrong. So B option is absolutely right. Okay. Okay. All right. No, ping pong, no. I wanted to square. So ping pong is having a doubt. In previous question, I was about to square. है ना? But then I realized that squaring is making things more complicated. So what I did is I multiplied alpha square in this so that it will become alpha raised to power 4, and it was making more sense, question more easier. So that's why I multiplied with alpha square, right? Squaring was making question more complicated. Yes, ping pong. I hope you got the answer. I hope you understood. Okay. All right. Now we have last method, third method. Okay. So the moment you see that you have one common root, so first thing is what you will look for is whether I know any of the two equations completely. If I know, just calculate two equations, take cases. Number two, if you don't know that whether like if you don't know both the quadratic equation, go for the equation solving. Put the value of alpha, eliminate, try to eliminate alpha and put the final that is common root in any of the two equation to get the desired result. Okay. All right. Now third condition, which will actually a rectification, like you need to cram that a lot, but it is like full-fledged method. It will give you answer for sure, right? Let me just show you that if you are given with two equations and the condition of one common root is given by this, let me just tell you how to remember the condition. So just, you know, CA, chartered accountant. This is the chartered accountant method. So start with CA. CA minus CA, right? CA. Now CA, right? So can you understand the cyclic order? This is C, this is A, this is B. So start with chartered accountant. CA, then AB is equals to AB, right? AB minus AB. Then AB is also done, and then BC. BC minus BC. Understood? Will you be able to write this? Now CA. So 1, 2, 2, 1, 1, 2, 2, 1, 1, 2, 2, 1. Like this. And don't forget, let me just write this with another color. Okay, white color, let's say. So square is there. Square. Do not forget this square. So CA minus CA ka whole square. Chartered accountant square method. Okay. So that's how you can apply for one common root. Okay. Let us just do this question with the help of the method number 3. That both the equation are having one common root. We need to figure out relation between A, B and C. Right. So C, chartered accountant minus chartered accountant. 1, 2, 2, 1 ka square is equals to AB minus AB is equals to BC and BC minus BC. So 1, 2, 2, 1, 1, 2, 2, 1, right? CA. So C1, A2. So C1 is what? C. A2 is what? B. Minus A times. So A times. So that's that. This is C2 and A1. So A times C. Sorry. C2. So A square. Okay. This is also A. This is also A. CB minus A ka square ka square. Now A1 B2. So A1 is A, right? And B2 is what? C. Minus A2 B1. So A2 is B and B1 over here is this B. And last B1 C2. So B1 is what? A1 B1. So B1 is B. C2 is this A minus B2. B2 is what? C and C1 is C. So this is what you are going to get. This is the relation between A, B and C. Now you can go ahead and solve it. So this, can you see? This is what we've got. And now you can go ahead, solve it and understand this relation. And yes. So you are getting A cube plus B cube plus C cube is equals to 3ABC. So yes, so they are asking you. So the condition related, so this is a factorization thing. If this a cube plus b cube plus c cube is equals to 3abc. So there are two cases. Either all three values of ABC are equal or a plus b plus c is equals to 0, right? So this is from the factorization thing. Clear? Now I was telling you about the both root commons. What happens when both roots are common? The question becomes extremely easy. It's just that the ratio of all the coefficients become equal. That means if two quadratic equations are given to you, then a1 by a2 is equals to b1 by b2 is equals to c1 by c2. And yes, if both roots of the equation are same, then equations are called identical. So these two will be called as identical equations. I hope this is clear. Clear? Chalo, let's do one question from JEE Main 2013. Okay, all right, this is my favorite question. Yes, let me just let me just see who does this question nicely. Let me just have a look. Yes, who does this question nicely? Let me just give you a chance. Yes, ping pong. Yes, we are going to have classes for 12th board. Yes. Okay, let us do. So they are having one common root, right? So why this question is my favorite? Because this is a googly question. One common root they are saying. But if I observe this quadratic equation, if I calculate discriminant of this, so it is b square minus 4 3s are 12. So discriminant is negative. That means we are going to have imaginary roots. That means this quadratic equation will be having one root, something sort of p plus iota q and p minus iota q. That's how your quadratic equation will be, right? Yes. And you know what? The question is saying they are having one common root. So what does that mean? That p plus iota q will be a common root for this as well. So they are sharing p plus iota q. And you know what? Have you seen those a young couple, the couple who are formed just like just in class 8th or class 7th, class 6 7 may they fell in love and they form a couple and they like stick together like fevicol. Wherever they will go, in school, in college, or in wherever they will go together. So basically our imaginary roots behave like young couple. In Hindi we call them nibba nibbi. Okay? So imaginary roots are nothing but nibba nibbi. They will go always together. They cannot go alone. P plus iota q cannot be separated from p minus iota q. That means if you try to make one between these two quadratic now, then what will happen? What will happen? Both root will be common. So it's a delulu. Both roots are common, right? So both roots are common. Clear? So this is a googly question basically, who are trying to manipulate you by telling you that one root is common, but actually what is happening? Both the roots are common. Why? Because p plus iota q and p minus iota q are inseparable. Wherever p plus iota q go, p minus iota q will be follow and vice versa. So if both the roots are common, then to what happen? You know, if both roots are common, then a upon 1 is equals to b upon 2 is equals to c upon 3. So the ratio is 1:2:3. Option A is absolutely right. Okay. Yes. So now you understood why this was my favorite question from 2013. So I used to take this question like till 2017. Till 2017 batch in every class I have taken this question. Okay. All right. Chalo. Now let us talk about the elephant in the room. So we always struggle, especially class 11th students, you always struggle with graph of quadratic graphs, right? We always get scared from the graphs. I have seen especially class 11th student and especially that beginner, class 12th beginners also struggle with graphs, right? But you know what? Graphs makes our problem extremely easy. Graph is nothing, graph is such a tool which is not making your life difficult, because we feel so, ki this much graph, quadratic ka graph ma'am, like biquadratic, cubic ke graphs are there, exponential function, there are very logarithm ka graph. So basically graphs are here to make your life easier, not difficult. Please understand, get this straight in your head. This is a tool which is making your mathematics part difficult, because if you go through the algebraic method now, you won't be able to solve that question in a faster manner. I hope you understand. So just spending some good time, quality time with the graphs is actually going to help you in the longer run, right? Okay, so let's just talk about the graph. So here, if I talk about y is equals to ax square plus bx plus c quadratic polynomial, right? So understand this fact that leading coefficient, so if your leading coefficient is positive, you will get a upward facing graph, right? So if your leading coefficient is positive, then your quadratic polynomial will smile. Can you see the smile? So you can just connect with this. So whenever in any quadratic polynomial, if your leading coefficient is positive, so what happens when you stay positive? Always smile, right? So that's why your quadratic polynomial ka graph will also smile. What happens if your leading coefficient, this is negative? So much negativity, that means sadness, right? So basically your graph will become sad itself, right? Graph will become sad, and the graph of parabola will be, the graph of quadratic polynomial will be downward facing. So this is upward facing, right? The graph is upward facing, the parabola is upward facing, this is downward facing, or the sad, this is happy graph, this is sad graph. Okay, clear? Yes. So can you see this? The moment you see y is equals to ax square plus bx plus c, if it is a greater than 0, leading coefficient positive, you will see a happy parabola over here. And if you like, you can clearly see that this is your sad parabola when your leading coefficient is negative. Okay, right? And now, so two things I hope about the graph, it is clear. Now what is the next thing? One by one we will study. Okay? One by one we will study. Now what about this point? This is called vertex of the parabola. Let me just tell you the definition of vertex of parabola. So suppose you are able to see the happy parabola, right? So if I like take a small pearl, if I take a small pearl and I drop this pearl or the ball over here, small ball, and I drop a ball over here, what will happen? It will like go directly aise karke, and it will swing, and at the end it will stop over here at the lowest point. Can you see? It will stop at the lowest point over here. This lowest point in that parabola is the vertex, and in this parabola the highest point will be the vertex, right? And the coordinates of vertex will be minus b by 2a comma minus d by 4a, x comma y coordinate, right? So I hope you remember these 2 points, very important. Okay? Clear? Right? Yes? Now let us understand in graph what happens when your discriminant is greater than 0. What happens if your discriminant is greater than 0? So understand this fact that when my discriminant greater than 0, I will have two different roots. So the value of x will be real. First thing is real, and the value of x will be 2, actually 2 real, I am going to get 2 real values of x which are different, which are distinct. That means my parabola will cut the x-axis at 2 different points. Can you see? This is my upward parabola. So if d is greater than coefficient is positive, that means upward facing parabola cutting my x-axis at 2 different points. And same, if my leading coefficient is negative, then my parabola will be downward facing, but my discriminant is still positive, that means to real, क्या हो गया ये, 2 real and equal roots. Can you see what is happening? 2 real x-axis pe it will cut twice. This is the significance of discriminant greater than 0. Now what will happen when my, that means I'm gonna get equal roots, or I can say that only one value of x I'm gonna get. So x-axis pe my graph will touch my x-axis at one point, touch at one point, right? This is how we show equal roots, right? This is upward facing parabola, leading coefficient positive. This is downward facing parabola, leading coefficient negative, right? But in both the cases, your discriminant is equal to 0. That means it will touch or it will cut my x-axis at single point. Now what about discriminant less than 0? That means no real value of x. So what does that mean, no real value of x? Understand this nicely, very important. So that means parabola will neither touch nor cut my x-axis. It will never ever interact with my x-axis, right? So yes, these are the 6 types of, so only 6 types of graphs are possible. I have already showed you. So this is a greater than 0 upward facing parabola, and this is flowing in air. Can you see x-axis? It is neither touching nor cutting. Again, it is flowing below the x-axis. So this is completely below the x-axis. This is completely above the x-axis, right? Yes. Okay. Clear, clear, clear. All right. Okay. So now let me just tell me something about this. Okay. Let's discuss these 2 points, very important points over here. So suppose I have this parabola, this is y-axis, this is my x-axis, this is my parabola, and this point is what? X is equals to minus b by 2a and y is equals to minus d by 4a, right? Yes? है ना? Clear? Now what I'm asking you is range of this parabola. Okay. So range of parabola, if it is, so basically I'm gonna take 2 cases. So first, when you are having upward facing parabola, that means when you are having leading coefficient positive, then the minimum value of y, this is minimum value of y. Can you see? The y coordinate is this. So the minimum value of y in upward facing parabola will be what? So y is equals to minus d by 4a. So range will be what? Y belongs to minus d by 4a to infinity, because in upward facing parabola by value will be infinity, right? This is your case number 1. Now for case number 2, if you are having downward facing parabola, In this case also, your vertex is same, minus b by 2a minus d by 4a. So, but can you see is this? Minimum value is minus infinity. That means y max will be minus d by 4a, right? And yes, so I call the range is minus infinity to minus d by 4a close, right? So I hope the range of your quadratic polynomial is clear to you. So they can ask you about the range of this quadratic polynomial. Any questions, any confusion, please let me know. ठीक है? All right. ax square plus bx plus c is greater than 0. Now understand, this is very important. What are they trying to ask? So suppose you have, let me just show you. Suppose you have y is equals to ax square plus bx plus c, and they are talking about ax square plus bx plus c greater than 0 for all values of x belongs to R. That means your quadratic expression will always be positive. This for all values of x belongs to R, positive. That means your y is always positive. And yes, this can only happen when graph will stay strictly above x-axis. And when my graph stays x-axis, that means it is upward facing parabola. First of all, this is my condition, by the way, a greater than 0, and should be less than 0 because I want to have imaginary roots, because I know for my imaginary roots my parabola will be flowing in air above x-axis, right? So if I have to write the condition for this, that my ax square plus bx plus c is greater than 0 always, that means leading coefficient positive and discriminant negative. And can you see the second point? Let me explain you the second point. So if I want my ax square plus bx plus c less than 0 for all value of x belongs to R, that means I want my parabola to stay below x-axis. Can you see? Completely below x-axis, right? So completely below x-axis matlab downward facing parabola, and discriminant again less than 0. That means I parabola to touch or even cut my x-axis. So a less than 0 and d less than 0. In both the cases, can you see discriminant is less than 0? In positive wala, your leading coefficient is positive. Negative wala, leading coefficient is negative. So please do remember all these three observations. It is very important, right? So these are the, it's already written. Can you see? Yes, this is a greater than 0, d less than 0, a less than 0, d less than 0, and this is your range, right? Okay. Yes, ping pong, you're absolutely right. When the curve doesn't touch x-axis, that means x की कोई real value नहीं है. There is no real value of x. Yes, we will study this. Actually, we'll understand this through the example. Now, let us plot the curve. Who is with me? Who is with me? Who is going to plot this curve with me? Okay, let me just tell you some nitty-gritties of the curve. So, before actually plotting the curve, na, acha, listen to me carefully. One very important tip I want to share regarding graphs, regarding each and every graph. Okay. So, please do not jump and just start plotting the graph, because I have seen that the moment you see it minus x. Yes, absolutely, clap me. Do not do that. This is absolutely rubbish. Okay, please take your time. I know that you will know this. Please take your time. Please collect some more data before actually getting into the plotting of graph. First thing is downward facing parabola. The first observation is I will dot downward facing parabola. Okay. Second observation which you should do, which I have not told you, that always talk about the constant term. So constant term is 3. That is y-intercept is 3. Y-intercept is 3. That means the curve, the graph, the parabola will cut the y-axis at 3. How? Because the moment you put x is equals to 0, you will get y is equals to 3. That means 0, 3 is the point of that curve. So please be careful about, so this is also one more data. Now you can just plot this graph, and 0, 3 is, now you can just plot this, है ना? Because downward facing everybody will know what would be the position of your graph correctly, right? Okay, now third thing what you can do is you can just figure out the vertex, and fourth thing you can figure out the roots, and you are done. So vertex is what? Minus b by 2a. That would be minus of minus 2 upon 2 into minus 1. So that will 2 cancel, minus minus cancel. So minus 1 is your vertex. So vertex will be here, right? This will be your vertex. Okay? Vertex. So vertex will somewhere lie over here, minus 1. Okay? Alright. Now what about roots? So if I try to solve it, minus sign common, x square plus 2x minus 3. Can I solve this? So it will be 3 है ना, x square, okay, plus 3x minus x minus 3. Yes, absolutely. So it will be x plus 1 and x plus 3, right? X plus 1 and x minus 1 and x plus 3, right? So 1 and minus 3, right? 1 is first root and minus 3, that is like this. Minus 3 is another root. Now you can go ahead and plot the curve. So this is your vertex. It will look like this and it will look like this, right? So this is how your parabola will look like. Yes, Hardik is asking me ki ma'am, do you have any problem because your face is so reddened? Yes, I have problem. So I have a skin disorder, rosacea, right? So you can Google it, rosacea. What happens in this? So whenever you face any like lights or sun, or there are multiple triggers basically. So whenever I stand like 2-3 hours in light, so in front of me I have many lights over here. So basically my face is photosensitive. So my face becomes red. Okay, so this is my curve. Now they are asking me the range, right? So they are asking me the range of this quadratic equation. That's what we have left. We have figured out everything, but range. So range is simply, you don't have to plot the graph for range. Minus d by 4a. So minus d, discriminant, who is going to tell me? Discriminant is b square, that is 4 minus 4ac. So plus 4 3s are 12. So 16 is your discriminant. So minus 16 upon 4 times minus 1. So your minus minus cancels. So this is 4. So basically 4. So this value will be 4. Minus 1 comma 4 is the highest point. So the range will be, you guys gonna tell me. So the range will be minus infinity to 4. Yes? Okay. Now again, range of this. So for this, so we have to understand the graph of this. So now clearly for so 4, 1, 2, 3, 4, right? 4 will be this. What about the vertex? So vertex will be minus b by 2a. So that will be minus of 2 upon 2. So minus 1 is the vertex. So vertex is over here, right? And minus 3 say minus 2, you're going to plot the curve. So minus 2, minus 3, right? So this is your vertex. This is upward facing parabola. And -1 pe what value you are getting? -1. The moment I put -1, just calculate value at -1. So it will be 1 minus 2 plus 4, right? So this will become 3, right? So 3, right? -1 pe we are getting a 3 over here. So that's how your, basically this is your vertex, and yes, this is 3, and this is how you're going to get. So this is your -2, this is your -3. Now they are asking you what? Range of this curve. Now can you see that you're only -3 and -2, right? So you can clearly see that I'm gonna get -3 and minimum value at -2, right? So put x is equals to -3 to get maximum value. So maximum value will be equal to 9 minus 6 plus 4. So it will become 3 plus 4, 7. So the moment you put x is equals to -2, you will get a minimum value, right? So that will be 4 minus 4 plus 4. So 4 will be the minimum value. So range will be y belongs to 4 to 7, right? 4 to 7. Okay. All right. Clear? है ना? 4 to 7. Clear? So basically how to, without graph, how will you solve? So first of all, let us understand vertex is -1, which does not belong to this category. If it is belong to this category, then the method would have been different, right? If it is doesn't belong to this category, then we can clearly say that okay, the graph will be straight line, the graph will be parabola ka only straight line wala hissa, the straight wala hissa will be there. So that's why -3, -2 pe minimum and maximum value we can get. Now can you see this question? Again, range of this particular quantity. Who is going to, and x value is restricted. Again, calculate the vertex. So vertex is what? Tell me. Vertex is minus b by 2a. So that would be -1 by 2 to the 4, -1 by 4. And can you see my vertex belong to this category? And this is an upward facing parabola, right? -1 by 4. So this is -1. This is your vertex. And 0 pe value, it is becoming 1. And yes, that's how your graph will become. Can you see this will be your graph? And you're looking for -1 to 1. So between -1 to 1, the lowest value will be at x is equals to -1 by 4. That is your vertex. So minimum value will be given by x is equals to -1 by 4. What about maximum value? Now maximum value will be given either by 1 or -1. Whichever value is far away from vertex, na, that value will, so maximum value clearly we can see at x is equals to 1. So let us calculate maximum value first. So x, here I will get 2 plus 3 plus 1, 4 is the maximum value. What about the minimum value? 2 by 4 minus 1 by 4 plus 1. So this will be 1 by 4 plus 1. So 5 by 4 is the minimum value, right? So yes, can you see that vertex belong to your interval? So vertex pe you are going to get, okay, maybe I made a mistake, 2 by 16. So this is 1 by 8. Yes. So now you can calculate the value of minimum value will be 5 by 8, right? 5 by 8. Right? And maximum value will be 1. Right? Correct? Yes. Okay, dark devil. My voice is breaking. Okay, maybe. Is it fine now? Is it better? Let us do this question. Let us understand this question now, which was asked in JEE in 2021. And you know what? In 2021 specially, I saw this question. And in 2021, they started asking the quadratic inequality question. And actually, this is good question. क्या बोल रहे हैं ये? What are they trying to say? There is a quadratic equation which is always positive. We have just studied this, by the way. My quadratic equation is always positive. That means my leading coefficient should be positive and my discriminant should be negative, remember? So leading coefficient is 1, which is always positive. The only condition is my discriminant should be less than 0. Let us calculate discriminant. So b square minus 4ac less than 0. So b square 2 times 3k minus 1 ka square whole square, right? Minus 4 times 8k square minus 7 less than 0. This is my discriminant being less than 0. So 2 ka square is 4, 4. Take out, cancel it. 3k minus 1 ka whole square is 9k square plus 1 minus 6k minus 8k square plus 7 less than 0. Can you see? 9 minus 8 is 1. So k square minus 6k plus 8 less than 0, right? We just need to solve this inequality and that's it. Method of intervals. 4 2s are 8 and 4 and 2 is equals to 6. So it is k minus 2, k minus 4 less than 0. If I plot 2 to 4, so k, value of k lies strictly between 0 to 4. So they are asking me integral values of k. So k could be 3. The integer k for which this inequality, na? So the only value of k, integral value of k which is satisfying is option A. Yes? Yes. So basically 9 March onwards we'll be starting for April attempt, right? After you are done with your mathematics board paper, we'll be starting as soon as possible, right? We are giving you break for board examination basically. है ना? So yes, k is equals to 3 will be the correct answer. Now, yes, so there are some questions related to graph of quadratic equation. Can you see? Find the signs of a, b, c in the following graphs of quadratics. Okay, so we need to figure out the sign of quadratic equation. Okay, sign of my quadratic equation. So I can clearly see that over here my a in this, can you see? This is your c. So c a upward facing parabola है, इसीलिए upward facing parabola, that's why your leading coefficient a is positive. Now this is your c. So basically your y-intercept is positive. Can you see this is positive y-axis? And your y-intercept is positive, right? So your c is positive. Your c is positive. Okay. And what about b? So this is your vertex. X coordinate of yours, this is minus x-axis. Right, so x coordinate of your vertex, that is minus b by 2a, is negative. Or what you can do is you can simply multiply this with a negative sign. So it will become b by 2a greater than 0. And this a is again positive, so you can just simply ignore this a. So b is also positive. So a, b, c, all the three quantities are positive in case number a. What about your case number b? Let us study this case number b. Yes. I am talking in English only. Whatever I said in Hindi, na, I repeated. I by mistake said one sentence in Hindi. Then I immediately realized and I translated in English, and I made sure that no concept is missing. So whenever I start speaking Hindi, I immediately realize and I immediately repeat that sentence in English. So do not worry about that. Okay. So what about this? A is clearly negative in this. C, can you see this is y negative? So C is also negative, right? What about the vertex? Vertex ka x coordinate of vertex minus b by 2a is also negative, right? So can you see this minus sign over here, and a is also negative? So negative cancelled out with this negative. So B will also become negative. So all A, B and C, all three are negative in this particular case. Yes, Veron, absolutely right. Absolutely. I'm super duper happy. Okay. Alright, so first case everything is positive. Second case everything is negative. Okay. Now we have got the last topic of the session, so it will take hardly 7 minutes, but it is very important, right? The topic is very important, location of roots. Okay? So we have our function f of x and we have a quadratic equation ax square plus bx plus c. ठीक है. So basically location of roots में what kind of questions they will ask? What type of questions? So basically they will actually give you some different cases. That first case is that both the roots are greater than real number k. ठीक है. And what they can do is both the roots are less than real number k. ठीक है. Third, one root is greater and other root is less than k. ठीक है. And they can ask you that exactly one root lie between k1 and k2. Right? Yes. Are you getting my point? These are the cases. So let us start with the first case. Both roots are greater than real number k. Suppose you are given with ax square plus bx plus c is equals to 0, right? And both roots, so condition is both roots are greater than k. ठीक है. So if we try to plot the graph of it, so what we will do is, first of all, we need to take two cases. That my parabola is either upward facing or downward facing. So to simplify things, what I'll be doing is I'll be dividing this whole equation by a, so that my expression becomes like this. So now I don't need to worry about upward or downward facing parabola. I know that my leading coefficient is 1. And I know that my parabola will always be upward facing, and I only need to make the cases for upward facing parabola. So suppose my k is here, real number k is here. Now what I want is my both roots should be greater than k. That means my alpha and beta both lie after k, right? So either this will be my case, or both roots are equal, then also I am fine. Either this is my case, right? So upward facing parabola, so I know I will divide, the moment I'll see question, I'll divide by a. So leading coefficient 1 is there. I don't need to apply any condition for my leading coefficient. It is fixed, okay? Now what I need to know is over here, first thing is my discriminant should be greater than or equal to 0, because if I am saying that my both roots are greater than k, my roots at least should be real. My roots cannot be like imaginary. That is the first and foremost thing, right? And if I talk about this k, so my value at at x is equals to k. Can you see the moment I put? So suppose I take this as function of x, and this is my polynomial or my function. So f of k should always be positive. So second thing is f of k is positive. And what about third thing? Third thing, the condition will lie on my vertex. Can you see my vertex exactly lie over here? And my vertex on the number line is greater than k. That means minus b by 2a becomes greater than k. These are the three necessary and sufficient condition for my both roots to become greater than real number k. We will solve the problems as well. Do not worry, but understand this, that we will always talk about three things. Whenever we talk about location of roots, that where are my location of roots located with respect to a real number k, we will talk about discriminant, we will talk about value of that function at my real number k, and we will talk about the position of vertex with respect to k, right? Okay. Now let me just think about my second case. So now again x square plus b by a x plus c by a is equals to 0, and the question says both roots are less than k. ठीक है? So if I try to draw the graph now, k will be after my alpha and beta. Alpha and beta will be less. So this is my graph, either this or this. So first thing is, again, discriminant should be greater or equal to 0. Value at x is equals to k. Can you see that is positive? Again, so f of k is coming positive. What about third thing? So third thing, clearly that my vertex is smaller than k. That means minus b by 2a is less than k. Are you getting my point? Yes, this video is absolutely for JEE Main. Okay. Are you getting my point? Now third. X square plus bx by a plus c by to 0. And what was the third case? Who is going to tell me? Okay. One root is greater and other root is less than k. Right? So that means, what is my situation? So one root is greater than k and other root is less than k. How do we plot it? Upward facing parabola. So basically this is my alpha, this is my beta. One root is greater than k. That means my k will lie in the middle of alpha and beta. Now can you see? My beta is greater than k and my alpha is smaller than k, clearly. So I can clearly see that over here, I actually need to write discriminant obviously will strictly greater than 0. We don't need to write the condition for discriminant. We don't need to explicitly write. Even if you write, it's not incorrect, but it will not give you anything, right? So this is waste of your time. But if you write, it's not incorrect, okay? Basically, the value of function at x is equals to k is negative. Can you see the value is coming negative? The moment you put k, you get negative. F of k is less than 0. The only condition is this. No need to apply the condition in vertex and all. Clear? All right. What is the fourth condition? Exactly one root lie between k1 and k2, right? So third is exactly one root lie between k1 and k2. So in here what is happening? You have two values k1 and k2 and one root is stuck over here. So either alpha is stuck over here and this is your beta. This is one of the cases, or what you can do is, this time, so this is your k1, this is your k2 and this is your beta. Beta is stuck between k1 and k2, right? Yes, so these two are two different cases. And what will be the condition? So clearly the k1 value is positive in first case, k2 value is negative in first case. But it is getting reverse. In like second case, k1 is negative but k2 is positive. That means we know that what is happening, either of basically k1 and k2 follows opposite sign, right? So I have to write f of k1 multiply f of k2 will give me a negative sign, or simply f of k1 f of k2 is less than 0, right? If one is positive, other should be negative. If other is positive, first one should be negative. So only condition about the fourth case. So these are the four cases related to location of roots. Any confusion? Yes, JEE Advanced 100%, 100% you can use this for JEE Advanced as well, right? Yes. Okay. So we are actually done with this particular location of roots concepts. Now the whole thing is problem solving. Let us solve this problem. Okay, so we have a very nice problem, very beautiful problem over here, which says that this is a quadratic equation whose leading coefficient is automatically positive. So I am so super duper happy that I don't need to divide it to make it positive. Okay. Has x is equals to 2 lying inside the roots. So the part A says that x is equals to 2 lies inside the roots. That means between the roots, right? So this is the case. So for first case, you just have to make f of 2 less than 0. That's it. That's all you have to do, right? First, f of 2 less than 0. So f of x is given by x square plus 2k minus 1x plus k plus 5. Just put the value of x is equals to 2. So 4 plus 4 times k minus 1 plus k plus 5 should be less than 0. So finally 4 से 4 cancels. 4k plus 5k plus 5 less than 0. K is less than minus 1 is the correct answer of this part A. Perfect. Yes, give me a big thumbs up. Right? Clear? Shall I move ahead? Let's talk about part B now. Part B says that value of k such that one root is less than 2, other root is greater than 2, right? One root is less than 2 and other root is greater than 2. Again, same thing. Can you see this is the same thing, same solution? Same situation, same solution. Yes, one root is less than 2, one root is greater than 2. It will become same graph. So f of 2 less than 0, we have done that. So k is less than minus 1, same thing. Okay, part B is also done. Now part C. Part C says that this quadratic expression is having roots of opposite sign. What does that mean? Opposite sign, that means one root is negative and one root is positive. That's how we are going to get. Right? When one root is negative, one root is positive, that means the value of this function or this polynomial or this parabola at x is equals to 0 is negative. Basically, f of 0 is negative. If this is your f of x, then f of 0 is negative. That means k plus 5 is negative. The moment you put 0, this is gone, k plus 5 is negative. K is less than minus 5 is what you're going to get. Yes? Option C done. Let us talk about option D now. Right, so which has roots such that 5 lies outside the roots. Okay, what does that mean? That if this is your quadratic polynomial, then 5 lies outside the roots, either here or here. Okay? 5 lies outside the roots. Okay, so that means that first of all, the first condition in this is your discriminant should be greater than or equal to 0. Second is, if 5 lies here or here, in both the cases, can you see that f of 5 is greater than 0? So these are the two conditions you need to apply, take intersection or, So discriminant greater than or equal to 0, let us apply. So x square plus 2 of k minus 1x plus k plus 5 is your f of x, right? Discriminant greater than or equals to 0, 2k minus 1 ka square minus 4k plus 5 greater than or equal to 0, right? So 2 ka square 4 se 4 cancel, square plus 1 minus 2k minus k minus 5 greater than or equals to 0, k square minus 3k minus 4 greater than or equals to 0, right? And we have k minus 4 and k plus 1 greater than or equals to 0. So basically we have minus 1, 4. So 4 se bada greater than 4 and less than minus 1. And we have what? F of 5 to become greater than 0. This is our second thing. So 25 plus 10 times k minus 1 plus k plus 5 greater than 0. So it will become 11k. So 25 minus 25, so 30 minus 10. 30 minus 10 is 20. So basically we are getting k is greater than minus 20 by 11. Minus 20 by 11 is 1 point something. So we are getting k is greater than this. Intersection of these two quantity will give me this area and 4 to infinity. So final is what? Minus 20 by 11 to minus 1. So minus 20 by 11 open to -1 close, union 4 to infinity. This will be my answer. Let me just show you. Yes. -20/11 to -1, union 4 to infinity. Because discriminant will greater than or equal to 0 will give you this. And f of 5 greater than 0 will give you this. So taking intersection, you will get this. Okay. Clear? ठीक है, let us move on to the last part. Has both roots greater than 5? Both roots greater than 5. So clearly, we need to write first discriminant greater than or equal to 0. Second, understand this, f of 5 is greater than 0, but this is not it. We need to write vertex ka position as well. So vertex minus b by 2a is greater than 5. 3 conditions we need to fulfill. Take intersection of all 3 values and we are done. Okay? E part, shall I leave it to you guys? Will you be able to do? Both roots greater than 5. So 5 pe value is positive. So this is we have done. Discriminant greater than or equal to 0 we have done. Position of vertex is also important. So vertex is always greater than 5. So 3 things again. Can you see both roots are greater than 5? F of 5 greater than 0, discriminant, and vertex greater than 5. This will give you 3 different ranges of k. And if you take common, you will get no solution. So this is your homework. This part is your homework. You need to do this part by yourself. And yes. Okay. So yes, we are done with today's session. But before I go, I will leave you with this question. This is again a homework question. It was asked in JEE 2009. The question says that we need to figure out the smallest value for which both the roots of this equation are real distinct, that means discriminant is greater than 0, okay, and have values at least 4, right? So please solve this question and let me know your answer in the comment section. And even if you're facing any difficulty, just let me know. I will take this up in some upcoming sessions, okay, right? So yes, okay, all right. So let me just tell you one very important thing. So this we are done with quadratic equation backlog express. We'll be meeting tomorrow for another chapter. But before I leave, before I say bye-bye to you all, I have something to tell you all, that we are launching a batch which is Sankalp batch, okay? And this is specially designed for your IIT JEE preparation. There are some features related to the Sankalp batch. You can see on your screen that regular tests and assignments will be given to you. Regular live classes will be delivered to you. India's best teachers are going to teach, and unlimited doubt solving will be the most important feature of the Sankalp batch. Along with that, you will be assigned with a personal teacher, and you will be given with a lot of PDFs annotated and without annotation as well. Along with that, can you see the results of previous students related to the similar kind of batch as well? So they have improved the marks, they have cracked the IIT JEE examination, and yes, they have become toppers of these competitive examination. Okay, so these are some of our results from the previous batches. You can see on your screen that 8 students were scoring 100 percentile subject wise. I am talking about 9 students scored 99.9 percentile, again subject wise above 99.9 percentile, right? And these are the numbers you can see. And you know what, if I tell you about the percentage of selection, right, that is actually very crucial for selecting any batch, that you see that how many students were enrolled and how many selections were there, right? So basically we are having that percentage is absolutely high for Vedantu Sankalp batches. Okay, all right. So yes, these are a few of our results. So you can see 9 Vedantu students scored 99.9 percentile in first attempt of JEE Main 2024. And you know what, till now they have second attempt as well. You never know, these students, some of these students might score a proper 100 percentile, because now they are experienced and we are actually working hard on them. Okay, all right. So this was all about the results and all. So you can just decide for yourself and you can just choose this Sankalp batch for yourself. The link is given in the description box. And one more thing I would like to tell you, okay, that let me just check. Yeah. So for the Sankalp batch, registration form is given in the description box. I can see, right? And yes. All right. So this is me, Namrata, signing off. I'll see you all tomorrow in the next backlog chapter. Also, please let me know in the comment section what chapter do you exactly want for the upcoming session, so that I can just take your feedback and plan my schedule accordingly. Okay, this is me, Namrata, signing off. I'll see you all tomorrow.